You know how in the movies AI seems to just get it? It's fast, it's intuitive, and it's always one step ahead. Well, we might finally be closing in on that. Today, we're going to look at a new kind of AI that does something radically different. It doesn't just predict the next word, it predicts the meaning itself. And trust me, that one little shift could change absolutely everything. So here's the big problem we've been stuck with. We have these super powerful AI models, right? But the moment you try to put them in something that needs to react now, like a pair of smart glasses or a robot trying to navigate a room, they just can't. They're too slow, they use too much power, and they just can't keep up with the speed of real life. So where's the logjam? It's not about raw power, not really. It's about the fundamental way we've designed these AIs to think. See, they're built to think and speak one single word at a time. And that step-by-step process, that's the very thing holding them back from understanding our world in real time.
To really get this, we have to look at the current standard, something called a vision language model, or VLM. These are the AIs that can look at a photo of, say, a cat on a mat and describe it to you. But the crucial part is how they do it. They build that sentence one piece at a time, one word or token at a time. And that's exactly where all the inefficiency is hiding.
Okay, let's just walk through how this works. A VLM sees an image. Then it has to predict the single most likely first word. Let's say it picks A. Then, based on the image and that word A, it predicts the next word, maybe fluffy. Then the next, cat. You see the problem? This word-by-word generation is just incredibly expensive. The AI wastes a ton of energy on tiny details, like should it say fluffy cat or hairy feline? The meaning is the same, but it's burning cycles on the phrasing. So, if thinking in words is the problem, what's the solution? Well, this is where a brand new architecture from Meta AI comes into the picture. It has a bit of a mouthful of a name, the Vision Language Joint Embedding Predictive Architecture. So let's just call it by its much catchier nickname, VL-JEPA. Now, I know this diagram looks a little intense, but the core idea is actually just brilliant. Instead of building a sentence word by painful word, VL-JEPA does something way smarter. It looks at a scene and predicts an abstract idea of the entire meaning, all at once. It captures the gist of what's happening in a neat little digital package called an embedding. And this is the real difference between the two ways of thinking. The old way is kind of like a stenographer in a courtroom, meticulously typing out every single word. The new way, VL-JEPA, is like a sharp executive assistant who just listens and gives you the main takeaway. It focuses only on the core meaning, which, as you can imagine, makes the whole learning process way, way more efficient. Of course, this is way more than just a clever idea on a whiteboard. To prove this thing really had the goods, the researchers put VL-JEPA in the ring. They set up a direct, head-to-head competition with a traditional VLM to see which one was really smarter and faster. And the results? They were pretty staggering. In a totally fair fight, same data, same amount of training time, VL-JEPA just blew the old model out of the water. I mean, look at these charts. The blue line for VL-JEPA just shoots up way faster and gets more accurate than the red line for the old VLM. Whether it was captioning videos or classifying images, it learned quicker and just flat out performed better. And get this is the real kicker. It got these better results while using a predictor with half the moving parts, 50% fewer parameters. That's like a smaller, more efficient engine winning a race against a giant gas guzzler. It's a massive leap in efficiency. Being efficient during training is one thing, and that's awesome. But the real magic, its true superpower, comes out when you need it to perform live, in a real-time streaming world. It uses this amazing trick called selective decoding. So because VL-JEPA is always thinking in terms of meaning, it can just watch what's happening without constantly having to talk about it. It only decides to speak, to turn that meaning into actual words, when the meaning of what it's seeing actually changes in a big way. It's always aware, but it only chimes in when it has something new to say. So how much better is this? The research shows it's nearly 3 times more efficient. It can achieve the exact same level of performance as a model that's just constantly chattering away, but with a tiny fraction of the work. And what's so cool is that all this efficiency doesn't cost you anything in terms of what it can do. This single model is like a Swiss Army knife. It's not just for captioning. It can pivot on a dime to handle visual Q&A, finding a specific video you're looking for, or classifying images, all from the same core architecture. It's incredibly versatile. Okay, so We've been deep in the tech. Let's pull back up. What does all this actually mean for us? Why does an AI that predicts meaning, not words, really matter for what's coming next?
Well, this is the key to that real-time AI revolution. This unlocks the kind of tech we've been dreaming about for years. We're talking about AR glasses that can actually describe the world to you without the battery dying in 20 minutes. We're talking about robots that can react instantly to a changing room. This is how we get to AI assistants that can finally keep up with the speed of a human conversation.
And this gets right to the heart of it. As the researchers themselves said, the whole grand vision here is about building machines that can truly understand the physical world we all live in. That's the end game.
So what we're looking at here is a huge leap forward. By teaching an AI to predict abstract meaning, we're not just making it faster, we're making it fundamentally smarter. And it leaves us with a pretty mind-bending question, doesn't it? If an AI can learn to predict the future meaning of what it's seeing, what other kinds of abstract ideas could it learn to predict next?